Hello Pre-Algebra students, this is Chapter 8.3, Using Intercepts. In earlier parts of Chapter 8, we graphed using tables of solutions. Now we're going to learn to use x and y intercepts to graph linear equations. Let's start. You can graph a linear equation quickly by recognizing that only 2 points are needed to draw a line. It is often convenient to choose points where the line crosses the axes. The x-coordinate of a point where a graph crosses the x-axis is called the x-intercept. On this graph, you can see that our x-intercept is at -6. That is the point where our line crosses the x-axis. The y-coordinate of a point where a graph crosses the y-axis is called the y-intercept. The graph shown here has a y-intercept at 4. If you want to find the x-intercept of a line, you substitute 0 for y on the line's equation and then solve for x. If you want to find the y-intercept of a line, you substitute 0 for x on the line's equation and then solve for y. Let's work through an example where we do just that. Let's find the intercepts of the graph 3x minus 2y equals 6. We'll begin by solving for the x-intercept. To solve, we'll let y equal 0 and solve for x. So let's rewrite this equation with y valued at 0 and solve for x, which has a value of 2. So the x-intercept is 2. Now let's solve for the y-intercept. We simply let x equal 0 and then solve for y. And our y-intercept is -3. Now let's use the intercepts to graph this linear equation. This is the same equation we just worked through, 3x minus 2y equals 6. Remember, our x-intercept was 2. And our y-intercept was -3. So we'll graph this equation by first plotting the x-intercept. The x-intercept will be at the coordinates 2, 0. So let's go ahead and put that on our graph. Now let's graph the y-intercept, which will be at 0, -3. Now we complete our graph by drawing a line between the 2 points. And there is our linear graph for 3x minus 2y equals 6. Now try these 3 checkpoint problems on your own. Find the intercepts of the equation's graph, and then graph the equation. Press pause while you work. We have one final concept to work on when you return. Let's finish up Chapter 8.3 by writing and graphing an equation based on a word problem. You are canoeing along a 12-mile stretch of river. You travel 4 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times for the trip. Give 3 possible combinations of paddling and drifting times. Let's begin by writing an equation using words to help us understand what we want to put together here. So to write an equation, we're going to let x be the paddling time and y be the drifting time, both in hours. So our paddling distance is going to be paddling rate, which I'll label as PR, times paddling time, and we're going to add that to our drifting rate times our drifting time, and that's going to equal our total distance. So our equation will be 4x because our rate is 4 miles per hour, plus 2y, because our drifting rate is 2 miles per hour, and our total distance is going to equal 12. All right, so here's our equation, 4x plus 2y equals 12. Let's move that onto our next screen and begin the graphing process. Let's begin by finding our x-intercept. We'll find that by simply replacing the y with 0 and solving for x, which gives us an x value of 3. So the coordinates for our x-intercept will be 3, 0. Now let's solve for our y-intercept. And once again, we'll simply replace our x with 0 and solve for y, giving us a value of y equals 6. So the coordinates for our y-intercept will be 0, 6. Okay, let's go graph this. Let's graph our x-intercept and y-intercept to get our first 2 possible combinations of paddling and drifting times. Then let's solve for a third possible combination. If you'll recall, our question asked us to give 3 possible combinations of paddling and drifting times. Let's begin with our x-intercept, 3, 0. That means that you could, theoretically, paddle for 3 hours and not drift at all, and complete your 12 miles in 3 hours. Now let's graph our y-intercept, which is at 0, 6. At that point, you would drift for 6 hours without paddling at all. Just hang out in the canoe and take a ride, and get to your end destination in 6 hours. Now, let's go ahead and connect those 2 dots. To make our linear equation. And you can actually see another point on our line where we could paddle for 2 hours and drift for 2 hours. Let's see if that works in our equation, however, if we have 2 and 2 as our points. So if x equals 2 and y equals 2, does that work in our equation of 4x plus 2y equals 12? Well, it gives us 8 plus 4, which does indeed equal 12. So you can see here that we actually used our graph to find our missing point. Okay? So here are our 3 possibilities. We could either not paddle at all and drift for 6 hours, we could paddle for 2 hours and drift for 2 hours, or we could paddle for 3 hours and not drift at all. All right, folks, thanks for your work on learning to use intercepts. When I see you tomorrow, we'll practice more with this new idea.